Welcome to Ask and Learn.
For this problem, we can use the ratio test. So these terms here are going to be our AN terms. For the ratio test, what we're looking is to see if limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. We're curious if that's less than 1. Okay, so when we look at this limit, the absolute value signs are just going to tell us that we can throw away this minus 1 to the n. And then we're going to have pi to the 2 times n plus 1 divided by 2 times n plus 1, that whole thing factorial. And then we're going to be dividing by the AN terms, which is the same as multiplying by the reciprocal. So we'll be multiplying by 2n factorial over pi to the 2n. Whoops, a little bit of difficulty here. Okay, so we're curious to see if that's strictly less than 1. If it happens to be equal to 1, then it just means that the test is inconclusive. It could be convergence, it could be divergence. But if it's less than 1, then we know that these terms are approaching 0 fast enough to where we get convergence to happen. Okay, so when we work this out, so this is pi to the 2n plus 2 after we expand this. So we get the 2n's to cancel out here. So after we make some cancellations with our pi terms, we just get pi squared. Okay, and if we remember how the factorial works, 5 factorial, for example, is 5 times 4 times 3 times 2 times 1. So 2n factorial is 1 times 2 times 3 times 4, all the way up to times 2n. And then down here, we're doing the same type of multiplication, except we're going all the way up to 2n plus 2 after we expand that. So there's going to be a ton of cancellations that are going to be occurring. Everything is going to cancel out with these guys, except for the last two terms in the product that we're looking at here. Okay, so the last two terms being 2n plus 1 and 2n plus 2. Okay, these guys are not going to be canceled out with anything from over here. But everything else will be canceled out if you just remember how the factorial function works. Okay, so this limit turns out to be 0. So we're definitely going to end up getting convergence. The limit didn't have to be 0 to get convergence here. We just wanted it to be something less than 1. So if it's 0, then we're definitely good. So this is going to be a convergent series.